Hello everyone. Today we are going to be talking about area and perimeter again. I've already made a video for part one, but this is just getting into more of the detailed problem types you might see in area and perimeter questions and units and applications. So let's dive right in. So to begin, this is a basic strategy, but a strategy that is important to understand because when we're finding the area, we're determining the amount of space inside of an object. We want to know the space inside of an object, all this space. We measure that space with unit tiles. So a strategy that we use to determine area is to actually tile a rectangle or a square or a shape. How that works is we look at our side lengths, okay? So let's say that this side length is 4 feet and this side length is 6 feet. This might be a TV or a mirror or a floor, whatever. We want to measure it to see what the total area is by tiling this figure. So first thing we need to do, look at our length and our width. Length is usually the long side, width is the shorter side, but we know with multiplication, because of the commutative property, it doesn't matter which factor goes first. So when we're tiling, we're literally going to draw tiles in, but there's a way that we need to do this. So if I look and I see that there's 4 feet and this on our width, I'm going to draw 4 rows. It's kind of like an array essentially. So we're going to make 4 rows. So if I'm making 4 rows, I know that I need to draw 3 lines in our plane figure. Okay, so now I have 1, 2, 3, 4 rows, and then my length is 6. So I'm going to make 6 columns, but in order to make 6 columns, I'm going to draw 1 less than 6 lines. So I'm going to draw 5 lines. So 1, 2, 3, 4, 5. And now we have 6 columns. 1, 2, 3, 4, 5, 6. So we're good. And like I said, now we have square units inside of our shape. Okay, we were measuring the square units inside of our shape. So if we wanted to, we could count all of these up, and we could go 1, 2, 3, 4, 5, 6 square units, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 21, 22, 23, 24. So we know that the area of this figure is 24 square feet. Okay, that also could be written 24 feet squared. That little 2 at the top is also how you can write squared. But the idea is that I want you all to see is that the area is measured in square units, and unit could be a foot, an inch, a mile, a meter, anything you can measure with, but it's going to be perfectly square. So that's how we measure this, by using squares inside of our plane figures. That's how we're measuring that. So that's how the tiling strategy to find area. We also know that we could do the quickest way would be 4 times 6 equals 24. Because we know that area is length times width, or width times length, because of the commutative property, equals area. Okay? That's the tiling strategy. Next, we're going to find the perimeter given the area and one side length. So we know that to find the perimeter is you add all side lengths. Add the side lengths. But what happens when you don't have both side lengths? So in this rectangle, we would have the area is equal to 30 square units. We know our area. We know that this area in the middle is 30 square units. If we tiled this, there would be 30. But all that we know is that the length, the long side, is 5 units. We don't know what this is. We know that this is 5 because rectangles have 2 equal sides. The sides are equal length. So this side and this side are going to have equal length, and this side and this side are going to be equal length just because of the properties of rectangles. So we know that this is 5 units, so this is 5 units. We know that the total area is 30. How do we figure out what the missing side length is going to be? Well, if we know that area is what? Length times width. Length times width. So if we fill in the blanks here, we know that our length is 5. So 5 times something is equal to what? 30, right? So we're good at this. We've been practicing these, filling in, finding the missing factor. So 5 times what equals 30? There are different approaches to this. So you could do 30 divided by 5 and find the quotient. We could list the multiples. That's a good strategy. I like that one. You could skip count by 5s. It's the same thing. You have 5, 10, 15, 20, 25, 30. Now let's count how many multiples I've listed. 1, 2, 3, 4, 5, 6. Okay? So I know that 5 times 6 is equal to 30. 5 times 6 is equal to 30. So that would say, so this would be 6 units. And because this side is 6 units, we know that this side is also going to be 6 units. So now we can find the perimeter. Let me clean this up a little bit. We've been doing a nice job showing our work. But now we want to focus on the perimeter, since that's what the question is asking. We want to find the perimeter. So to find the perimeter, we need to add all the sides. So we need to add 5 plus 5, and then 6 plus 6. So we know 5 plus 5 is what? So 5 plus 5 equals 10. 6 plus 6 equals 12. Now I'm going to add all the side lengths together to get 22, what? 22 units. 22 units. So let's talk about this. Our first step was find the missing side length. And we did that by we knew that the area was equal to 30 and one side length was equal to 5. So we said 5 times what equals 30. Then you could either list multiples, list the multiples, or divide. 30 divided by 5 equals what? Any strategy that you can use to find the missing factor or find the quotient. They both work to solve this problem. And then once you find that, you're going to add all side lengths. Okay? Those were our steps for this type of problem. So if you're ever given asked to find the perimeter given the area and one side length, that's how you would approach this type of problem. Next, we're going to determine the missing side length given the perimeter. Given the perimeter, how am I going to determine the missing side length? So we know that the distance around the outside is 18. The distance around this outside is 18. We know that this one of the side lengths is 6 units. Let's say it's 6 inches. We'll go with 6 inches this time. So let's say that this is 6 inches. If this side length is 6 inches, by the property of rectangles, we know that this side length is 6 inches as well. Okay. The perimeter is 18, so we know that the whole thing is 18, and we're missing these side lengths. So we know that the missing side lengths are going to be 18 minus 6 plus 6 is what? 6 plus 6 is 12. So we know that that's covered. We've accounted for this part and this part. So 18 minus 12 is 6. And then we've got that's 6 represents this and this together. So how do we separate that? We need to half it, right? We need to divide it by 2. So we know that 6 divided by 2 is what? 2 times what equals 6? 2 times 3 equals 6. So we know that our side length is going to be 3 inches. Next, we're going to talk about the distributive property. We've been working on distributive property in our previous multiplication unit. This is going to be a review of that, but it's very applicable to finding area and perimeter, because the main idea of the distributive property is that we want to take a rectangle, break it into 2 smaller rectangles, find the area of those smaller rectangles or figures, and then add them together to make the math easier. So what we're going to do here, it's kind of laid out for us. We're going to think about our distributive doctor. We're going to find the area of this rectangle. Then we're going to find the area of this rectangle, and we're going to add the areas together, okay? So rectangle 1, let's think about this. If the side length over here is 8, we know that the side length over here is also going to be 8. But you could have counted this. We get 1, 2, 3, 4, 5, 6, 7, 8. Okay? So if I want to find the area of the blue rectangle, my multiplication sentence is going to be what? 8 times 5. Those are going to be our factors. 8 times 5. Okay, I'm going to put those in the parentheses to know that they're grouped together. And then we're going to add that to the area of the pink rectangle. The pink rectangle. So I'm going to put my plus sign here. And the side lengths of our pink rectangle are also the first side, because these are the same, 8. And then we see here that at the top it is 1, 2, 3, 4, 5, 6, 7. They tell us that, but we can also count and double check. It's always good to double check our work. So we know that we can find the area of this rectangle. So we would, by multiplying and adding 8 times 5 plus 8 times 7. Those numbers are a lot easier to add together or multiply together than 8 times 12, because 5 plus 7 is 12. That's tougher. We haven't really practiced our 12s a whole lot. So we're saying that 8 times 5 plus 8 times 7 is going to be easier. So instead of, we know that 8 times 12 is equal to 8 times 5 plus 8 plus 7 because of the distributive property. The same amount of space is taken up in both of these rectangles. It's the same area. It's just a different way of approaching it. Okay. So then from here we see that 8 times 5 is 40, and then 8 times 7 is 56. And we're going to add those together. 40 plus 56. The area is 96 square units. There are 96 squares in this rectangle. We just use the distributive property to help find the area. Okay, we'll be practicing this some more. Now we're going to find the area of some rectilinear figures. Rectilinear figures are just rectangles, two or more rectangles placed together. At times they can be a little bit tricky, but I'm going to show us some strategies that we can use to help find the area of these. So to begin, what we want to do is divide or partition our rectangles into smaller rectangles that we can imagine or that are separated. So we're going to treat this, we're going to find the area of this rectangle. That didn't show up. We're going to find the area of this rectangle, and then we're going to find the area of this, and we're going to add them together. Now, with this example, we could count, right, because it's already tiled. That's a possibility, but in the future, we're going to see rectilinear figures that have bigger areas. So we're just going to use this as a model, as an example. So let's look at this rectangle first. So we know that this one side length is 1, and this top here is 4. So to find the area of that, we're just going to do 1 times 4, and we know that that's equal to 4. And we can see that as well. 1, 2, 3, 4. In our bottom rectangle here, rectangle 2, let's look at our side lengths. We're not going all the way up here. We're not doing that. We're just considering this area that I'm circling right now. So we can see that this side length is 1, 2, 3. It tells us this. So that's going to be one of our factors. Times, and then our bottom is 2. Okay, so 3 times 2. 3 times 2 equals 6. Okay, so to find the total area of the rectilinear figure, we're going to add these two together. So 4 times 6 equals 10 square units. And if we added these together, or if we counted them all, tiled it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, same thing. This is a more basic example, but I wanted to show you all this to get the understand the concept. Let's do another one. Here we have to determine where we want to split our figure. So there's different ways we could do this. We could draw our line right there, which is a good option. Or some people might draw it here, which is fine as well. Both work. So remember, we're finding area of both figures and then adding them together. So let's look at rectangle 1. So let's look at our, we need to find length and width. So length and width, I'm going to box it in here. So we know that we need to find the area of this, it's a square, right? So we know that the one side length is 2, and the other side length is 2. Don't be confused by this 4 right here. When you split the rectangles up, this 4 goes away, okay? We're changing the side length, okay? Because we've essentially broken the rectilinear figure into 2 separate rectangles or squares, whatever shapes you have. Don't do 4 times 2, because if we did 4 times 2, we wouldn't be accounting for this space, or 4 times 4. Can't do that either right now, because we would have an error in our number of tiles. So for this one, we want to do 2 times 2, and we know that that's equal, 2 times 2 is equal to 4 square units. And then we're going to find the area of rectangle 2 down here. So let's count. We want to find the total area. So we know that, let's look at our side length at the bottom here. So this is 1, 2, 3, 4. So that's 4. And then we want to look at this area, okay? So we're not going all the way up here. No, we're staying down here at the bottom in this orange space. So we know that one side length is 4, and then the other side length is going to be 2, because 1, 2. We're not going all the way up here. We're not going, there's nothing there, so we cannot account for that. So that, we just stop at 2 and not go all the way up to 4, because even though it's tall up here, we've already accounted for the area in rectangle 1. We did that there. So the area for the second rectangle is going to be 4 times 2, which is going to be 8 square units. So we're going to add those together. 4 plus 8 is 12 square units. Okay? That's the second part of our area and perimeter unit. Hopefully this is helpful. We'll be practicing a lot, and let me know if you have any questions. Thanks so much.